The question asked here is, first part, arrange the following as per the given instruction in the brackets. So the first question asked here is cesium, sodium, lithium, potassium and rubidium. We need to arrange this in the increasing order of metallic character, right? So the answer will be lithium, then sodium, then potassium, then rubidium, then cesium. So it is because the metallic character increases down a group in the periodic table as the decrease in the ionization energy and increase in the atomic size. So this will be the answer of arrangement according to their increasing metallic character. Now the second question is magnesium, chlorine, sodium, sulfur and silicon. We need to arrange them in the decreasing order of atomic size. So the answer is sodium has the smallest atomic size, then magnesium, then silicon, then sulfur, then chlorine. Because the atomic size decreases across a period left to right, that is, and increase down a group in the periodic table. That's why we get this arrangement. Now the third question asked here is, we are given with sodium, potassium, chlorine, sulfur and silicon, and we need to arrange them in the increasing order of ionization energy. So the answer will be, the increasing order will be potassium, then sodium, then silicon, then sulfur and then in last chlorine, because the ionization energy decreases down a group but it increases across the period, that is left to right, and these elements are given from left to right period itself, right? That's why the order is like this. Now the fourth question of first part asked here is, we are given with chlorine, fluorine, bromine and iodine, and we need to arrange them in the increasing order of electron affinity. So the answer will be iodine has the least electron affinity, then bromine, then chlorine and then fluorine. Fluorine has the highest electron affinity. This is because electron affinity generally decreases down the group. However, fluorine electron affinity is slightly lower than chlorine due to its small size and hindrance between the electrons, right? Now the second part of this question is, choose the most appropriate answer from the following list of oxides that are given here. These are the oxides. Each answer may be used only once. So first we have given with a basic oxide. So we know that all the metal oxides are basic in nature. So the answer will be sodium oxide, that is Na2O, and magnesium oxide, that is MgO. Now the second question is an oxide which dissolves in water and forming an acid. So we know that all the non-metal oxides form acid when dissolved in water. So the answer will be sulfur dioxide and carbon monoxide, that forms sulfuric or sulfurous acid, and carbon monoxide forms carbonic acid, right? That is H2CO3, right? And the sulfuric acid is H2SO4, right? Now the third question is an amphoteric oxide. So from the given list only aluminium oxide shows the amphoteric nature, so the answer will be aluminium oxide, that is Al2O3. Now the fourth question asked here is a covalent oxide of metalloid. So here we know that only silicon is a metalloid, that's why the covalent oxide of a metalloid will be silicon dioxide, that is SiO2, right? So this is the answer of second part. Now moving towards the third part. So it is given that element X is a metal with a valency 2, that is means plus 2 valency, because metal tends to lose electrons, that's why they get positive valencies, and element Y is a non-metal with a valency 3, that means it needs 3 electrons, that's why its valency will be minus 3. That shows that its outermost shell have 5 electrons in the outer shell. That's why the non-metal Y has a valency 3, that means it needs 3 electron to complete its 8 electron octet to get stable. So the first question asked here is, write an equation to show how Y forms an ion. So the answer is, if Y is a non-metal with the valency 3, it needs 3 electrons to form Y3 negative ion, right? The equation for the process will be Y plus 3 electrons, that forms Y3 negative ion, or we can say that Y anion, right? Now the second question asked here is, if Y is a diatomic gas, write an equation for the direct combination of X and Y to form a compound. The answer will be X is a metal with a valency 2, so it forms X2 positive ion, and Y is a non-metal that forms Y3 negative ion, right? The compound formed is neutral. So the formula of the compound should be X3Y2. If Y is a diatomic gas, the direct combination equation will be like 3 molecules of X combining with Y2 molecule to give X3Y2 as a compound. So I hope all these questions are now clear to you. Thank you.